All right, so let's take a look at a scenario here, and we're going to create a Venn diagram. And then another way that we can actually show this data is using a two-way table. So here we have 100 juniors enrolled in pre-calc at Lake Braddock Secondary School, and they're thinking about what classes they're going to take next year. So 55 of these students are going to take AP Calculus AB, 35 are going to take AP Statistics, and 10 are going to take both AP Calculus AB and AP Statistics. So we're going to let A be for the students who are enrolled in AP Calculus AB. We're going to let event B be for the students who are enrolled in AP Statistics. So since we talked about two-way tables in our first unit, let's create our two-way table. So again, for our two-way table, we're going to have our two variables, and we have our calc students. And then we're also going to say which ones are not doing calc, so no calc. Then we have our stats, students, and we're going to have no stats. Or another way to think about this is we will have A, and whoops, getting ahead of myself, A complement, and stats would be B, no stats would be B complement. Right? And what we're going to do is we're going to work our way from inside out. So we know that there are 10 students who are going to take both. So that's what we're going to fill out first. So we're going to fill out the both first. Then we also know that there are going to be 35 students who are taking AP Stats. So the total for AP Statistics is 35. If 10 are taking both Stat and Calc, that means that we have 25 who are taking Statistics but aren't taking Calculus. And then let's do the same thing here. So we know that there are 55 who are taking Calculus, total for Calculus. So that must mean that there are 45 here. Now how are we going to fill in this last box? Well, they told us that there's 100 total juniors that we're looking at here. We have 100 total juniors that we're looking at here. Right? Well, if 55 of them are taking Calc, that means that 45 are planning on not taking Calc. Okay? And if 45 are not taking Calc, and 25 of those non-Calc students are taking Statistics, that means that there must be 20 who are not taking Stats and not taking Calc. And if we take a look here, 45 plus 20 gives us our 65, and 35 plus 65 gives us 100. So lots of wonderful ways to check here with our two-way table. So how would we show this in a Venn diagram? Well, Venn diagram, we have two scenarios, so we would draw our two circles. And I would make sure you know how to make a Venn diagram, and perhaps even a Venn diagram with 3 circles. Right? As you can guess, I'm not the greatest circle drawer in the world, but we've got A and B here. Now, Venn diagram, I could draw the total amounts, or I could use a percentage. For this case, I'll use the percentages, but feel free to just throw in the actual values as well. So over here, we would always start in the middle. We have 10 students out of 100 who are doing both. So we always start here, okay, when we're making the Venn diagram. So let's ignore the fact that I could look at that two-way table and fill out the rest of this, and let's just think it through and do this way. All right. We know that a total of 35 students, so 35% of students, will be taking AP Statistics. So the total for B is going to be 35. Well, 10% is already here, so I know that 25% must go there. Right? And we know that the total for all of this, must be 55, because the total number of students, middle and here, are 55 for AP Calc AB. Well, if 10% is here, that means we must have 45% there, or 45 individuals. Right? Now the last thing you need to make sure that you include is the outside. Well, to find the outside, I just add all 3 of these up, so 45 plus 10 plus 25. When we add all of that up, it gives us 80, or 80%, which means there must be 20% up there. Okay? So that's how we fill out our Venn diagram into a table. Now, how are we actually going to find our values? Well, first question asks, what is the probability that a randomly selected student enrolls in both AP Calculus and AP Statistics? So let's write a probability statement for that. I've already defined event A and event B up here, so I can use that. So I'm trying to find the probability that A and B both occur. Well, that would be this region right here, right? Okay. So that's going to be 10 out of 100, or 10%. If I was looking on my Venn diagram, the overlap probability of A and B would be this region right here, which is 10%. Okay. What's the probability that a randomly selected student only enrolls in AP Calculus? So that would be the probability that they are in AP Calculus and not in Statistics, not in AP Stat. So that would be this region right here, which is equal to 45 out of my 100, or 0.45. Only in AP Calculus AB, so the probability of A and not Statistics rather, would be this region right here. Let me see that on our Venn diagram we already have our percentages, so that would be 0.45. Alright. Now we're looking for what's the probability that a student is not enrolled in AP Calc. That would be this right here. That's the total. So probability not in AP Calculus AB, and that would be 45 out of 100, or 0.45. Not enrolled, well, that would be everything outside of this circle. The outside in this part of B. So when we add those together, we get 20% plus 25%. And what do you know? It's 45%. Looking over here, what is the probability that a randomly selected student does not enroll in either AP Calculus AB or AP Statistics? So the probability that they're both not in this. Or you could say that the probability that they're not in either of these, AP Calculus or AP Statistics, either way, that's going to be this region right here. Let me see that that's our 20. 500, or 0.2. Same thing here, probability that they're not in A or not in B. So here's my A. Oops, looking at not A. Ignore that. There's my not A. Luckily my key actually has this right. Here's my not B. And we're looking at the overlap, which again, if we ignore that, the overlap is just the outside. Sorry about that. So just the outside here, which we already calculated as 20%. All right. What's the probability that knowing a randomly selected student is enrolling in AP Statistics, that they are also enrolling in Calculus AB? So this right here is going to be our conditional probability. So we know we're given that they're an AP Statistics student. What's the probability that they're also taking AP Calculus AB? Well, to find this, we just do the probability of A and B over the probability of B. So the total probability of B, or the total amount of B, is here. So basically we're limiting ourselves to just AP Statistics students. And we're trying to figure out what's the probability that they're also in AP Calculus. So for this, for our two-way table, I can just take this total right here, the intersect of the two, 10, and divide it by the total number of AP Statistics students. So we have 10 over 35, and I might use my key for this, which is about 0.286. And again, for here, probability of A given B, probability of A and B over probability of B. Again, we're limiting ourselves to our B section, and we just care about what proportion of that entire B circle is made up of here. So what's the probability of A and B? That's our 10%. Over the total probability of B. Well, we add these together to get the total probability of B. It's not this, it's both of these together. Add these together for your denominator. 0.35, which is going to be 0.286. Alright. I want you to try this one on your own. Okay, try that one on your own. You can check the key when you're done to see if you got it right. But for now, we're going to take a look at the back. Okay. So we have the proportion of teachers in school that have a bachelor's degree is 80%. The proportion of teachers who have taught more than 15 years is 30%, and the proportion of individuals who have taught more than 15 years and have a bachelor's degree is 24%. So let's make our Venn diagram. Let event A be a bachelor's degree, and event B be teaching more than 15 years. Okay, so we'll let this be A, let this be B. And I've already defined what they are. If I had not defined what they are, I would need to define those letters. So we're always going to start in the center of our Venn diagram with what the overlap is, if we have that. So the proportion of individuals who have taught for more than 15 years and have a bachelor's degree, the intersection is 24%. So 0.24 in our middle. The total percent who have a bachelor's degree, all of A is 80%. Well, 24 of that's already in here. So that must mean that just A is 56%. And the total proportion of teachers who have taught for more than 15 years is 24%, which must mean that there is 6% who have taught 15 years don't have a bachelor's degree. And then to figure out the outside, we are just going to add these up. 0.56 plus 0.24 plus 0.06 gives us 86%. And so there's 14 on the outside. Right. Now they're asking us to find the total probability of A. Well, the total probability of A would be the total probability that we have a bachelor's degree. That's given to us. Or we can add these two numbers together and find out that that's 80%. Right. Now let's find the probability of A given B. So again, we can use our formula for this. We know that A and B is 24, and we know that the total probability of B, this total probability, is 0.3. And when we calculate that out, we find that it's 80%. Interesting. Let's take a look at C. So the total probability of B, well, that's more than 15 years, is 30%, or we can add those two together. to get our 30%. And here we have the probability of A and B. In this case, A is after the dash, so it would be over the probability of A. So that's going to be 0.24, right? There's our intersect, over this total probability of 0.8. And we find when we divide those that that is also equal to 30%. Interesting. So, if the probability of A is equal to the probability of A given B, if I'm choosing out of the entire group of teachers, what's the probability that I choose somebody who has a bachelor's degree? 80%. If I'm choosing out of the teachers who just have taught more than 15 years, what's the probability that I choose somebody with a bachelor's degree? Also 80%. So it doesn't matter. The fact that I've been teaching for more than 15 years does not change the probability that I have a bachelor's degree. Right? But what about the other side? Well, we find that the probability that a teacher's been teaching for more than 15 years is the same as the probability of that a teacher's been teaching for more than 15 years, given that they have a bachelor's degree. So that's the same probability there, which means it's independent. Okay? If I know that I'm choosing a teacher who has taught for more than 15 years, the probability that I then choose somebody with a bachelor's degree is the same. It's still 80%. That's what independent means. That's what independent events mean. Okay? So the probability of an event occurring does not change given the event, given another event, or the independent event has occurred. Right? And how do we prove it? This is important. How do we prove that events are independent? Well, we need to show that the probability of A is equal to the probability of A given B, or the probability of B equals the probability of B given A. So only need to show one of these two. All right, example number 3. We have Miss Hammond's AP Stat class, so I'll probably change this to Mr. Whitesell's, maybe to Miss Silver. So Miss Hammond's AP Stat class only consists of juniors and seniors, or Mr. Whitesell's AP Stat class only consists of juniors. Juniors, 3% of the class is juniors, while the remaining are seniors. Construct a Venn diagram or a two-way table to organize this information. So I'm going to construct a Venn diagram for this. So in this case, is there any overlap? Is it possible for juniors and seniors, for a student to be both a junior and a senior? No. So I'm going to make two separate circles here. Then A will be juniors, and then B will be seniors. Make sure you define those on your own if you're creating letters. Okay? So in this case, we know that 3% are juniors, okay? And the remainder are seniors. So B is actually going to be all of the rest of this, which would be 0.97. So if I was going to draw this correctly, I would put the entire outs. I would have B be the entire outside. But in this case, we're just going to draw it this way and just say that the outside is 0. Okay? Now, what's the probability of A? Well, the probability of A is just 0.03. What's the probability of A given B? Well, again, the formula for that would be the probability of A and B over the probability of B, which is, well, what's the probability of A and B? When do these overlap? They don't. So it would be 0 over 0.97, which is just 0. Probability of B, well, there's a 97% chance of that happening. The probability of A and B over the probability of A, well, we already said that that is 0 over 0.03, which is also 0. Now, what we call these events right here, where there's no overlap, are called mutually exclusive events. And since the probability of A does not equal the probability of A given B, and the probability of B does not equal the probability of B given A, we would call these events dependent. Right? And mutually exclusive events are always dependent. Again, mutually exclusive means cannot occur at the same time. All right. Hope you found this interesting and cool. I hope you have a wonderful day and good luck on your work.